All right, here we go. This is what this section is really about, is these basic 8 graphs. So these are, we can call them the basic 8. These are 8 different functions which are, you can put together to do all kinds of other functions, and we're going to study sort of variations of these functions later on. But it will help for a lot of stuff in the rest of this course to just kind of know what these look like. So you're going to need to memorize these graphs. I made a set of flashcards on Quizlet.com, which I think will help. I'll include a link to that set of flashcards and talk about it a little bit after we've gone through the actually graphing them. So, so yeah, you can see I tried to organize them here in sort of a reasonable way. You've got x squared. This graph is the basic parabola. Hopefully you already know that one from chapter 3 and chapter 4. 1 over x squared we haven't looked at yet, so we'll have to explore that. The square root of x, we've looked at that a little bit. And x and 1 over x are kind of related. You can think of these as reciprocals of each other, is the word for that. And x cubed and the cube root of x we know are related too. And then also the absolute value is another one. So to understand what these graphs look like, it's important to know how to get a graph from the table. So like that will help understand what the actual shape has to do with the formula. So for the first one, just f of x equals x. This is a really simple formula. So for example, f of negative 2, if you just replace x with negative 2, the result here should just be negative 2, because you've just replaced the x over here with negative 2, and that's the result. F of 0 is also equal to 0. F of 1 is equal to 1. So this is just a graph that the x and the y are always equal to each other. So it's got these points here. We've got negative 2, 2 here. So the x is negative 2 represents the input with all of these, and the y coordinate represents the output. We've got 0, 0 right there. 1, 1 is right here. 1 is halfway between 0 and 2. So if you draw a line that goes through those points, that is a graph of f of x equals x. And yeah, you could also just think of it as a line with slope 1 and y-intercept 0 if you want. You can think of this as y equals 1 times x plus 0 if you want to think of it in slope-intercept form. So it's like a basic line. You can think of this as the basic linear equation. And here's the basic quadratic equation. We know that if we take negative numbers and square them, you always get a positive result. So this is going to be 4. Likewise, negative 1 squared is 1. The result of squaring 0 is 0, 1, and 4. So this is still just the same old y equals x squared parabola you've seen before. And so if we graph those points, we're going to have negative 2, 4 is right here. Negative 1, 1 is here. 0, 0, 1, 1, and 2, 4. And you notice that it does have one point in common with the original linear function. The graph is a parabola, kind of like that. My parabolas are so ugly. Okay, something like that. So then let's look at this basic cubic function. We can start with the easier positive numbers here. So if we want to know h of 0, h of 0 means taking that number 0 and cubing it. So 0 times 0 times 0 is 0. So that's why you get that there. And if you want to find h of 1, the thing that goes right here, that's going to be 1 cubed, which is 1 times 1 times 1, and that result is 1. So that's that. H of 2 means 2 cubed. Two times 2 times 2 is 8. We got that. And if you have a negative number, remember a negative number cubed is still negative. So for example, when you plug in h of negative 2, the two negatives here are going to cancel out to make positive 4. And you'll get 4 times that last remaining negative 2, which gives you negative 8. So this is negative 8 here. And if you plug in negative 1, that will be negative 1 times negative 1 times negative 1 comes out to negative 1. So that will give us these points here, negative 1, negative 1. And negative 2, negative 8 is over here. 0, 0 is actually a point on all of these graphs. And we got 1, 1 in common, and 2, 8 is up here. So the cubic function is a lot steeper than either the basic linear function or the basic quadratic function. It also has a property that when x is negative, y is negative. So that's the difference between x cubed and x squared. With x squared, whenever x is negative, y is positive, but x cubed can become a negative function value for negative values of x. All right, let's keep trudging through this. We got a lot of these to graph. We want to figure out how the formulas affect the shape of the graph. So I just want to talk about what happens when you plug some numbers into absolute value. So for example, if I want to find f of negative 2 here, I'll work one of these out and then kind of fast forward through the rest. So f of negative 2 means the absolute value of negative 2. And the absolute value of negative 2 is 2. So that means this result is 2. Likewise here, you could just do the absolute value of negative 1, and that is going to be 1. The absolute value of 0 will be 0. The absolute value of 1 is 1. The absolute value of 2 is 2. So you get all these points. Let's plot these. We got negative 2, 2 is right here. Negative 1, 1 is right here. 0, 0 is here. We got 1, 1, and 2, 2. Now, it turns out that, yeah, this is just going to be a straight line on each one of these sides. So you basically just get the graph of just like a regular old y equals x out in this direction. But then if x is negative, the graph looks like y equals negative x out in this direction. So that is a graph of the absolute value function. Now, this is an interesting function. You can call it the reciprocal function if you want. I tried to pick some values of x here that will help explain why the graph of this is shaped the way it does, because it's kind of a weird graph. I want you guys to pay attention to this one. So, for example, let's say you plug in negative 4. So g of negative 4 is, well, according to the formula for it, should be 1 over negative 4. And 1 over negative 4 is negative 0.25. So that's what this result is. So that's going to be a point right about here, actually, where the y coordinate is negative 0.25. And in general, if x is a big negative number, this y coordinate is going to be pretty small, because 1 divided by a big number generally gets you something close to 0. So like 1 divided by 10 is going to be 0.1. 1 divided by 1,000, as you go way out to the left, is going to be 0.001. So it's got that. Then let's do g of negative 1 here. So according to the formula, this result should be 1 over -1, which comes out to be -1 here. And then an interesting thing happens here as well. If you do g of -0.25, that's going to be 1 over -0.25, and that result comes out to be 4, because like you can think, or -4 I should say, and you can think of it as how many times does 25 cents go into $1? 4 times. So, and also the smaller this number is, the smaller x is, 1 divided by that is going to give you a bigger result. So let's see how that looks on the graph. Already have this point, we have -1, -1, and then when x is 0.25 here, the y came out to be -4, which is about here. And in general, what will happen if x is closer and closer to 0, the result here is going to be 1 divided by a smaller and smaller negative number. So like 1 divided by, for example, 0.1 would give you -10, which is going to be way down that way. So it turns out the graph just gets closer and closer to the y-axis here. It doesn't actually ever cross it. And as x goes this way, the y-coordinates also just get closer to 0. And what happens if you do plug in x equals 0? At this point, 1 divided by 0 is undefined. So there's just no point in there. Nothing at all. So that means that if at the y-axis itself, there is no point. If x is 0, there's no value of y. So that means it has no y-intercept. Which is interesting. And if we plug in 0.25, the same thing will happen. 1 divided by 0.25 is going to be +4. 1 divided by 1 is 1. 1 divided by 4 is 0.25. So on this side, we're going to get that 0.254 point, 0.251, and 4.25. And it will be kind of a mirror image thing here. And in this case, we have this weird situation where the graph gets closer and closer to the x and y axes, but never actually touches it. So we can call those asymptotes of it. That's not really showing up. The x-axis is an asymptote, and the y-axis is also an asymptote of this graph. So I just wrote that out here so you know how to spell asymptotes. It is basically a line that the graph gets closer and closer to, but never actually touches. Now here's an exercise for you to do. I want you guys to stretch, take a break, try to touch your toes for a couple minutes. This has been a little bit of a slog, plugging in all these points and talking about it. I recommend doing that. And then in the next video, we'll finish up. We've so far done 5 out of the 8. And then the next video, we'll cover the next 3.